Okay, so these questions that we're covering, now they involve situations where the triangle is still not in front of you. So you have to figure out the triangle using some creativity or maybe some of these hints that we have here. Like I'm not asking you to invent anything too out of the box. Most questions that you're going to see do follow a certain pattern. For example, if you have an arc of a circle, or if you have the center of a circle, that's usually something that's valuable to a question. We also talked about symmetry. While in the question we covered last time at the end was not symmetric, this next batch of questions we're going to cover today and on Friday, there are questions that involve symmetry. Finally, there's questions involving circles and how they connect with each other. So as Denny mentioned in the chat there, and also Shalon confirmed that they did the same thing, if you have two circles that are touching each other like that, using properties of tangents and radii, because there's a tangent here. Let's get that tangent here. There's a tangent line there. That's 90 and that's 90. So what that means is that you can connect the two centers of the circle, and that distance is going to be the sum of R1 and R2. So we're going to use this pattern today. Actually, we'll use it today a couple of times. There's also the situation where you could have a circle that's internally tangent to another. In this case, you would you add the two radii. In this case, you subtract the two radii. So I'll put here R2 plus R1, and let's say R2 is the larger radius, so that'd be R2 minus R1. So we'll see those as well. Rule number 5 is more a nice one when you're dealing with architectural problems where maybe you have a blended curve and you can approximate the blended curve as two circles. So you see this blended curve here? You can think of it as actually two circles that are tangent to each other. And using that logic, a similar strategy is like this one here. So you can do that pattern. I will mention though the fifth rule here, or the fifth pattern, however you want to refer to it as, is certainly on the tougher side, and I'm not going to give you that one on a test. So I'll talk to you as we browse through the rest of the questions in this book. I'll talk to you about what types of questions you could expect to see or not expect to see. I do promise you though that the test is very doable, and I'm not looking obviously under the tight constraints that we have this semester to go too full force on you and pick every question to be hard. So I'm going to show you here question number 4, and using the rules and the skills that we talked about at the end of last class and continuing with that today. So let's take a look firstly in the question. One thing I would like to get out of the way is these fractions. So over here, that's 0.75 inches. The diameter is 0.75 inches. So can someone tell me what the radius is for the little circle over here? What's the radius for this little circle down here? Anybody in the chat? Nope. That's the diameter. Thank you, Shalon. So yeah, 3.375. Thank you, Zifeng. Also over here. Honestly, the nice thing is that you get to see me work under pressure. So if that's the worst I can see, then I'm not gonna complain. Honestly, if this is the worst I could get, I'm not gonna cry about it. So here we go. The diameter here is 1.880 inches. What's the radius up here, people? Can someone let me know? I think I see Denny's comment over there. That's good. So that's 0.940 inches. But we're going to use this information. to solve the question. Now, it really comes down to, can you locate the right angle triangle? Where is the right angle triangle? That's what you got to ask yourself, okay? If these questions, the topic is Pythagorean theorem, where is the right angle triangle? That's what we're looking to do here. So in this case, one of the rules helps us get that, because if you recall, this one over here, when you have two circles touching each other that are tangent to each other, what you can do is connect the radii and you'll get a straight line. So over here, I'll do that. I'll take the radii and get a straight line. There it is. That number, and that's very good, because that's actually how you would get that. If this is the two radii here, then you would have 0.940 plus 0.375. So definitely that answer is correct. That's 1.315 inches. It's the same thing. I just have the extra digit of 0. So that's 1.315 inches. From there, I think it's very natural to extend the base of the triangle and the height like that. So that's the other two legs of the triangle. The bottom of the triangle is D. No doubt that's what we want there. That's what we're trying to solve for. However, we need to get this thing here. If we can get this height here, then we're good to go. So I'm glad that you found it. So now, can someone tell me in the chat? Oh, Zifang, that's very good. So this answer here, this height here, let's talk about it because some people might not be sure. You take this blue height here, and then you subtract this blue height here. Now those two heights that I labeled in blue are the two radii. They're the two radii, the big circle minus the small circle. So I'll take the big circle radius and then the small circle radius and subtract them to get a desired result, which indeed I'm confirming the answer there. And there from my point of view here, I think we're good to go. We just do some algebra and I think we're done. So I'm going to continue over here. So we have here b squared plus 0.565 squared equals 1.315. You're most welcome. Can someone give me an answer there? Anybody got an answer on that? Confirmed. Thank you very much. I have to learn how to pronounce your name. So you're going to tell me if I did it correctly or not, okay? And tell me, or you can tell me on the mic, okay? Is it Mabubech or Mabubech? Or am I off? Am I totally off? Maha. I like Maha. If we played hockey together, I like your hockey name. That's your hockey name for me. My hockey name is Johnny. So it's Johnny and Maha. We're good? We're hopefully chilling. Okie dokie. So there you go, everybody. You absolutely, everybody's crushing it in the chat here today, so I'm very proud of you. There's your answer, 1.187 inches, and you can confirm that in the notes. It's a nice question. Well, yeah, we're going to do another one because it's the next question. I want to leave this open, though, for just another minute. I'll just pause from talking and give anybody an opportunity to copy down what they need to copy. So we'll just pause for 1 minute, okay? Nearest inch or second? Ram, are you referring to this question? Are you referring to assignments? Okay. Okay, so nearest inch is oh, okay. How about we talk about that one over email? Is that okay? Because it sounds like a very specific question. I don't mind answering that over email. Or you can stick around at the end of class. Yeah. So here's the next one. Now, in this one, we also notice it's similar to the previous question, but we also have the idea that there's a symmetry. You see how the question, you can cut it in half? So for that reason, you could actually just look at half the question. So I could erase, I'm at the mercy of my Blackboard here. But you could cut the problem in half. There you go. So that's what you can do here. And it doesn't matter which half you use. Yes, absolutely. So I'm just gonna do this. I'll literally just chop it out. There you go. So that's symmetry there. You're dividing and conquering. And we want the height. Now let's highlight the height here. We want this height, and we can break it up into pieces. We can break it up into 3 pieces. This part here is pretty straightforward because it's vertical. So is this part here. But this middle region's where it gets weird. And that's where you're going to have a triangle. And it's very similar to the previous question. So once we get numbers on this figure, I think we're certainly in a good position. Now, these are diameters. We don't want diameters. We want radii. So I'm just going to cross that out and put 5 centimeters. Nothing wrong with it. And that's the radius. And over here, that would be 2.5 centimeters. So anyway, let's talk about some numbers here. Can someone tell me how much this length is? What is that length? How much is that length? What? Very good. Now, if you don't mind, I'm not going to put the units either. So yeah, that's 5. And so up here, can someone tell me this length? How much is that length? Yeah, that's 2.5. Thank you very much. So now we have to deal with this pink triangle. Once we deal with the pink triangle, I think that we're in an awesome position to finish this question. So let's talk about pieces here and work it out. This is the hypotenuse of the triangle. That hypotenuse, I'm going to just draw the triangle over here nice and big. That's the same triangle, just away from the picture. So I haven't seen the comment yet, but this length here, can someone tell me what that length is? What is the length of the hypotenuse? Thank you, Maha. That is correct. That is 7.5. Because you're adding the 2 radii together. So this is 7.5. Not bad. How much is this? Very good. That's 5. So I'll just put that here. Oops. So that's 7.5. And then we have 5. Let's call this here, let's give it a name. I feel like calling it y. So I'm just going to call it y. So at this point, we're absolutely, coast is clear, my friends. Coast is clear now. We can do this question. So let's talk about some steps here. So the final step is this: h equals 5 plus 2.5 plus y. That's the final step of our answer. So once we get y, we're absolutely set. So let's draw an equation here to solve for y. So we can use the Pythagorean theorem. In this case, what's the longest side on this triangle? Which of these numbers is the largest side? Thank you. So make sure that you put that by itself. So I ended up getting this. Can someone confirm? Can someone confirm that number? Thank you. So our final answer is going to be the sum of those three heights individually, which is to two decimal places, 13.09 centimeters. And there you have it. All right, I'm going to leave this one on the screen for a couple minutes. So I'm going to just pause talking for 2 minutes. This one's a bit harder, so that's why. 2 minutes, okay? We'll go to the next one in 2 minutes. So, Shalon, to answer your question, there is an assignment this week, which is based on last week's material. And I'll have that, as you know, the assignments are due on Friday, but I do allow for late submissions at most by Sunday with penalty. So I'm going to have your marks for the assignments up by Monday. Next week, there's no assignment. It's just the test. Next week, just so everybody knows, and I'll make an announcement, next week, there's no lectures. There's no classes. There's just the test. So next week is just Friday. Friday is your test. There's no class on Tuesday, and I'll make an announcement. There's nothing happening next week. During test week, I do a freeze on everything. No assignments, no classes, nothing. Just the test. So you can take that week and you can focus just on the test. I am very much against last minute teaching. I don't like last minute teaching. I don't like doing that to people. So many of you in this audience, not many of you, all of you have the tools ready. I strongly believe by the end of today's class, you have all you need to know to do the test. I'll post this up on Blackboard at the end of class. And also the video I probably will post tomorrow, if not today. Just depends, because today I have meetings after meeting all day today. So anyway, I'm gonna go back here. Let's talk about this question. This is a really annoying question when you look at it, and it's another one that's done very this is one that's been on tests in the past that is not done very well. So the question is, you want to find out this length. Sorry, you want to find out this length here. So the most common mistake that people make is they go and do this. They try to draw from the corner up to B. This diagram, this idea is incorrect, because this circle here, we can't really do much with the circle, because the way that we've drawn this line segment, it doesn't really go through the center of the circle, and it doesn't really use the circle as part of the information. So before we start the question, just make a note here that we don't like diameters, we like radii. So that's 0.5 inches radius, because we'll need that shortly. And now the question is, how do we actually get the width there? So I'm going to do the following. I'm really going to zoom in on this figure, and I'll just get rid of this side panel a bit. So the key thing here is that we want to use the center of the circle. Yeah, basically the same as the last one, but be careful about that. We want to use the center of the circle. So for this one, I am going to just, I'll use the shape features here because I can't draw a straight line to save myself right now. So let's just do that here with a better mechanism on PowerPoint. So that's the line segment that we want. In addition to that, we're going to have some leftovers. You see the leftover right here? Can someone tell me how much that pink line segment's worth? What is that pink line segment worth? Thank you, Denny. Yeah, that's 0.5. Thank you, Shalon. 0.5 inches. Beautiful. And yeah, indeed, it's the radius. It's the little radius. And this blue line segment, the whole thing, can someone tell me what that length is? How much is it from here to here? How much is that? Maha is correct. Shalon, yep. Zifeng, thank you. That's 10.5. Beautiful. And there you go, my friends. We're almost ready to finish off this question. I hope you don't mind all these colors. I'm a colorful kind of person. I'm a very visual type learner, and they help, and hopefully they help you too. This length here, I'm going to give it a name. I'm going to call it x, which means that w is x plus 0.5. So if we can get x, then we've completed the question. However, we don't know what this height is. Can someone tell me how much that height is? Zifeng is correct. That is 9.5. It's very similar to the first question we did today. So yeah, 10 minus 0.5. Thank you. So that's 9.5 inches. So 9, whoops. So there you have it. And it's a very common mistake to have. That's actually the most common mistake that people make on the question. So it's not you. Many people actually make the same mistake. So what I'm trying to say is you're normal, okay? I mean that constructively. So let's go with that triangle and say that x squared plus 9.5 squared equal, oops. If we were in class in person, I would usually show you some mental math tricks, but I actually turn them into videos. So if anybody's wondering, there are ways to do these calculations in your head. And if you want to know how I do them, I can do these in my head. I made videos for these because many students asked me to how I did that in my head. So just saying there, if you're curious, can definitely share that with you, or I can tell you where to watch the videos. So anyway, that value there is roughly 4 point something. Can someone confirm? 4.472, right? I'll tell you in a second. Actually, I'll do that after the question. Thank you. Thank you, Denny. Yeah. 4.472. And to finish the question, so W equals X plus 0.5. So I'm just going to add 0.5, which is super easy. So what would W equal? What's our final answer? Thank you, Liban. 4.972 inches. Okay, so there's the last question we're gonna do today. I'm gonna revisit this question in a second, just for fun, okay? I'm gonna do something with you just for fun now. Yeah, that's the most common mistake, is to draw the line straight down to that corner. I'm telling you, that's why when I started off my explanation, it's not dumb, it's just a first guess. You're allowed to make guesses that are wrong. I do it all the time. The point is that you make a guess, you realize that it's not a good guess, then you adjust. That's how as humans we think. We don't If we just sit there in a room and just think about what's the best way to do something, maybe we'll never find it. But if you just make a guess, you can always adjust. I'm going to have some fun with you now, everybody. So here, let R2 be. So there's the question. If R2 is the radius of the big circle, the large arc, so R2 in this case is 10, and R1 is the small circle, which in this case is 0.5, what would be the formula for W in terms of R1 and R2? Do I have any takers in the chat? Anybody in the chat want to write down what they think the formula is? I'll give you a minute. I mean, this is not a 1-minute question, but can you piece together what the formula is? Well, it's going to be two terms. And if you look on the answer key here, you got 0.5. So it's going to be x plus 0.5. The 0.5 is actually just the radius of the little circle. So that's R1. It's going to be something plus R1. R2 is the big circle and R1 is the little circle. Denny, are you saying that R2 goes in the other blank, or are you saying that this R1 should be an R2? Okay, okay. So actually, it's quite a complicated formula. And by the way, what I'm doing here, let me just put this in green here, all right? Not on test. Okay. I don't mind staying until 1 o'clock. We're gonna end the class in 4 minutes, Shalon, as per the policy. So I'll be here till 1. That's no problem. But yeah. So I'll just tell you. It's pretty messed up, people. It has to do with this. You see this here? You have to think about how you got the 9-5 and the 10-5. So I'm just going to write down the formula, and for the stronger students, Maha is correct. Good job. That is amazing job, okay? So this is going to be R2 plus R1. And R2 is the big one, yeah? And then R2 minus R1. That's the formula, but that can be simplified through a lot of algebra, not too much algebra. That's the formula, people. That's very good work, Maha. Very good work. So that's the answer. You're welcome. You're very welcome. Yeah, so this last thing I did here is not on the test, okay? This is not for anybody to get, like, destroyed on a test. It's just something to have a little bit of fun, you know? It's all good. So what we're going to do next time is we're going to just do a few more questions like we did today. And we're going to work on the 3D Pythagorean Theorem. 3D Pythagorean Theorem I'm just typing something for you in the chat. So just make a note of that, okay? The 3D Pythagorean theorem, we're gonna do more of these questions. We're gonna do the 3D Pythagorean theorem next time, but the 3D Pythagorean theorem will not be on the test. The reason is I already created your test prior to this lesson. There's no point in going back and changing it because I really spent a lot of time making the test a very fair and representative set of questions for your material. So that's pretty much it, people. We'll continue on Friday with more questions, but I really want to put you at ease that what we covered today, if hypothetically you weren't here on Friday, you better be here on Friday because you're paying to be here, plus I have more stuff to show you. But hypothetically, if you studied based on everything up to today, I think that you would be very well prepared for the test. So anything we do on Friday is think of it as extra practice on some tougher questions. So yeah, that's about it. I'll stick around until 1 o'clock for individual questions, and after that, I guess I wish you a good week. We'll see each other on Friday.